pair, you have to know that the first number is X and the second number is Y. Second number is Y there. All right, is that clear?
Yes.
X comes before Y. Okay, so you literally, and I'll write the first equation here. You literally take X as -5 and Y as 3. You put those into the equation. Okay, so that's what the teacher's trying to show you here. It's like, okay, Y went in for 3, and then X is -5 minus 12.
Okay.
Is that clear? Like we take, I'll do it and I'll highlight it here.
Yeah, she just plugged them in. Yeah, I see.
Exactly. And you did one for the other. And what you hope is that they're the same.
Mm-hmm.
Okay. So on the right here, you have to simplify. You have to use order of operations, and you have to know to multiply before you subtract.
Okay.
So you have to multiply -3 times -5. Can you tell me what that is? I mean, you're allowed to use a calculator, whatever you're allowed to use in class, please use.
If you clear it, do -3.
15.
15, good. 15 minus 12.
Yes.
Okay. And what is 15 minus 12?
3.
3, good. And so what should happen here is the left should equal the right. And you have that. So basically all of this is what your teacher wanted to see in part A, but there's a little bit more. We have to do the same thing now in the second equation.
Okay.
Okay, so if you got all that down, we'll work on the second equation.
Do you have all of it down?
Yes.
Work on the second one?
Okay. Yeah, give me that verbal yes or no.
Okay.
So that I can't see you now. It's sometimes distracting.
I saw him nod.
Yeah. So we'll get the hang of this. You'll get the hang of my style, and make a lot of sense here. So again, you're going to substitute in for both X and Y. So that value of -5 is going in for X, and 3 goes in for Y. And so whenever you substitute for negative numbers, it's a good idea to put them in parentheses. Positive numbers, you don't have to. You can always show substitution in parentheses, but definitely for the negative numbers there.
My calculator's right there.
And please multiply -4 times -5.
It's 20.
Plus 3.
Equals 23.
Yes. And the left, yeah, the left equals the right. Happy, star, whatever you like to do. That's what you're trying to show. So that's what your instructor wanted for part A.
Okay.
All right, now for part B, I like the effort for part B. I mean, you put something down and you gave it a shot here. But I think you need to know what can happen when you have 2 lines. So there's 3 cases here. So if you have 2 lines, the first case is that they intersect at a point.
Okay.
Okay. So when they intersect at a point, you get an ordered pair as a solution. In your case, it's -5, 3.
Okay.
So if there's a place where they are both true, like meaning they work in both equations, which is what we just did, we showed that they work in the first equation and the second equation. That means it's where they intersect.
Okay.
Okay, so you would want to show that. Now, this is not the correct graph. Let me make but you don't even need a graph. What you need to say.
Okay. I see what you're saying. Yeah.
Yeah, which the instructor, so, and here's how it's graded. Like the instructor doesn't actually read your full answer most of the time. They look for the keywords. They're looking for intersect, point, check. Okay. If they don't
Okay.
see that, they're going to say, oh, he doesn't understand. They're just literally looking for keywords when they grade this thing, because they're grading like 30 of them. Plus they've got other classes. They don't have time to read everything you put down. Less is actually more in these situations.
Okay.
All right. Do we need to go through number 2?
Would you use substitution in this method?
So I'm gonna answer your question with a question. We talked about this last night. The only time you use substitution is when one of the variables is already solved for. Okay, so if we're going to use substitution, then that means that it, like one of these equations is already x equals or it's already y equals. Is that what you see over here on the left?
No.
No. So at first glance, you would say probably not. Okay, so if they're not explicitly solved for, the second thing is, well, can you make it, like, can you easily manipulate the system? Can you manipulate the system by adding something or subtracting something to get like an x equals or y equals? And again, the answer is no to both of those. So like
Okay.
the reason to use substitution is like the variables, one of the variables is already solved for, one or the other, or it's really easy to get it to be solved for.
Okay.
So we would want to say elimination here. And there is an explanation for why it's elimination that we should probably just talk about. And it's not because it's not substitution. That's not the right, it's not, oh, it's not that one, so it must be the other one. There's usually a reason. And I'm going to draw your attention to these two coefficients here, the 2 and the 6. Okay, so the reason is that 6 is a multiple of 2.
Okay.
And we can, like, since we haven't done one like this, I mean, maybe that didn't make any sense, but that is why it's elimination. Okay. A secondary reason is that -2 and +6 are opposite in sign. So probably the instructor would have taken either of these.
Okay. That makes sense.
But we should solve one. I mean, we're kind of jumping right into these. There's really a build up to learning how to solve systems. If we could start over, and maybe we'll get a chance to do that. But should we keep going? Should we solve the system using elimination, or should we go on to the next page?
We can go on to the next page.
Okay. All right. So number.
Can I ask a question?
Of
Do you
course,
think,
yeah.
like, do you think she would have accepted if he put that it's elimination because he knows it's not substitution because X and Y, like it's not solved? Do you think she would accept that answer or no? Like you think the two answers? I'm just thinking the way he thinks, and I'm wondering like if he'll in the next
Right.
test.
So it's a very, like, what you asked me is like a loaded question. It's like, well, is it okay to say that it's okay to do this thing because it's not the other thing? Like, I
Right.
don't know. I mean, if a student wrote that for me, I'd probably accept it because I feel like they're at least engaged in the process. But I also would have
Yeah.
told them over and over again, when you use substitution, I would say you have to have a variable solved for. You have to have a variable solved for. Now, at least was that made clear in class, like when you use substitution versus elimination?
Yes, I just didn't know really how to solve substitution.
Okay. So I'm not sure how to answer your question. Like, I think the problem is that his answer was kind of, you could say substitution. You just had to say that, like, I would solve one of the equations for a variable.
Okay.
But the reason the instructor made the problem this way, he's leading you through a sequence where it's like, okay, if you think it's substitution and you even explain it, you say, and I'm going to just snip this in here, and you say, yeah, because I'm gonna solve for one of the variables. Okay, like if you had wrote that here, solve for X, I can do that. He's now saying, like, or she is now saying, like, you need to do it. Like you just said it's
Mm.
substitution, and they're trying to tell you like, hey, maybe you made a mistake here because it's really hard to actually solve for X or to solve for Y.
Right.
And they're hoping that you'll see that or catch yourself, I think is the intention here.
Okay.
Um,
Thank you.
okay. So let's go, we go to number 3 or
Could we go to number 3, please?
He just
3.
said.
Oh,
Yeah,
sorry.
3 is correct. The graph is correct. Is this your graph?
Yes.
Okay, so the point of intersection is correct. Did you lose any points on this, or was it?
She wants us to show work, so yes, I did.
I see.
I just
see.
don't
Okay,
know how to show the work.
I see. Okay, so let me start from the beginning here. All right. Okay, so we want to take this first equation and we want to solve it for Y. Okay, so I'm going to rewrite it down here. Minus X plus 2Y equals 4. And I'm going to help you solve this for Y. Okay, because that was kind of a thing yesterday I saw that was a little unclear. We're going to add X to both sides. Okay. And I'm going to write
Okay.
2Y equals. Now that X, I'm going to put it in front of the number. Okay, so it's going to be X plus 4, X plus 4. It's always better to put that variable in front of the coefficient there. All right.
Okay.
And then from here, we're going to divide everything by 2. Division is not a choice. You have to divide everything by that number. You divide because it's multiplying. So you write Y equals, and then X divided by 2 is actually better written as 1/2 X plus 2. Okay. Now, I really would like you to go through this on your own, but I want to make sure we get through everything we can tonight. This is Y1. When your instructor wrote Y1, they wanted the first equation solved for Y. This is what you were supposed to put here. 1/2 X plus 2. Okay. So your instructor is big on work. Okay. They want to see the steps because your answer is correct, but in this class, you get graded based on showing your work. Okay.
Okay.
So now we're going to do the same thing for the second equation. 5X plus 4Y equals minus 20. So this time, instead of, so in the one on the left here, it was negative X. So we added X. Here it's positive 5X. You will subtract 5X from both sides. So this is 4Y equals. Now my preference is to put that minus 5X in front of the number, minus 5X minus 20, like that.
Okay.
And then just like in this line over here, you had a 2 in front of the Y. We have a 4 in front of the Y. What should we do to get rid of that 4? Divide by 4. Now you got to divide everything. It's not a choice. You don't pick the one you like because it works out better. It's unfortunately everything. So this is minus 5 over 4X minus 5. And this is what they wanted. This is Y2. They wanted that in the second box there.
Okay.
Now, the reason they're using Y1 and Y2 is it's a way to distinguish between the equations because they're both solved for Y. That one says Y, that one says Y. So they're trying to distinguish between the two of them. You see this in programming. You'll see this if we do some graphing calculator stuff later in the course. You'll see that as well.
Okay, thank you.
Yeah. Now your graph is correct. Okay. There's not really anything that needs to be shown on the graph. Like you have the right intercepts, you've got the right slope. But you could, so there's a few things you could do to kind of like enhance your graph for your teacher. First thing is you could label like X and Y, but that's kind of standard. You could put units on here. You could say like this is 1 and this is 1. The other thing that I think probably is missing is you don't specify which equation is Y1, which equation is Y2. All right, so if you go back to your equations, like this first equation, 1/2 X plus 2, that's this top one. And I know that because it's got a B value of 2, it's got the right slope 1/2. So your instructor either wants you to show like y1 here, or even the whole thing, 1/2 x plus 2. They want you to be more explicit. Like, you wrote the emails to me, or you've been writing emails to me the last 2 nights. They have been
Yes.
very, very clear. Like that level of detail, the tone of the email is very nice. It's inviting. It's like, hey, this is what I want to work on. Your teacher wants that kind of clarity here. Now, maybe you don't know what to put, but that's what they're looking for. They're like saying, look, it's not enough just to draw 2 lines. You need to give me a little bit more you're giving me here.
Yeah, so label.
And your emails are very well written. So I know that you can do this. You just maybe have to find out what to do to be
Okay.
able to do that. Any questions on that?
No, thank you.
Okay, so number 4 is really similar. So let's run through that one real quick and get you going. So 4, they want you to solve both equations for y. Okay, solve both equations for y. So let's take a look at that first one. Minus 3x plus 2y equals minus 10. Question for you, Luis. How do you undo minus 3x?
You add 3.
Add 3x. 3x, yeah. So this is 2y equals 3x minus 10.
And just a question real quick. Is
Yeah.
this elimination we're doing or substitution?
We're still graphing.
Okay.
We're still graphing. So they teach in this course three approaches. They first say learn how to graph them to solve, then substitution, then elimination.
Okay.
And the instructor's being pretty kind here. They're telling you like exactly what to do. They're saying like you will graph this to solve it. Okay. And that's why in the previous problem we didn't do any more work, because you already had the graphs, they already intersected at the right place.
Okay.
All right. Now what do we do from here? Well, how do we undo this 2 in front of the y?
We divide everything by 2.
Yes, everything. So this is y equals 3/2 x minus 5, like that. Any questions on that?
No, thank you.
Okay. Yeah, please interrupt when you do. Like, it's always helpful to do it in the moment. Now, I like to graph as you go. I don't like to wait. I think that's a bad strategy. So let's look at this equation right here. Can you tell me the slope and the b value of this equation? The slope and the b value.
The slope is 3/2.
Good. And the b value?
Is -5.
Good. You always, always, always start with the b value. So you go to your graph and you put a dot at where the y-intercept, the y-axis is -5. So you start from the origin, you go down 1, 2, 3, 4, 5. And actually, I'll do this in a different color to make it clear. 1, 2, 3, 4, 5. You put a nice dot there, okay? The slope tells you something, okay? The slope in words is the rise over the run. So when your slope is 3/2, the rise tells you that you're going up because it's positive, and the run is always to the right, always, always, always to the right. So from this point that I just made on your graph, you're going to rise, go up 3, 1, 2, 3, and right 2, 1, 2. And yes, the order matters. Yes, it's got to be in this order: up or down, then always right. So from this new point, we again go up 3 and right 2, up 3 and right 2. And if you've got a ruler, you should have a ruler. I'm gonna use the that didn't work out so well. I'm gonna just trying to make this nice. Let me see if I can get that here. So here we go. Kind of make it nice here through there. I don't know, it didn't work out great, but okay. So there's your line. All right. Is that okay? Is that clear?
Yes.
Great. Now we do the same thing for the other one, okay? We now look at 3x equals 10 plus 2y, okay? Now this one's different than the other ones. Like we're used to having x and y on the same side. This does not have that, but your goal is to solve for y. It's to get y by itself.
Okay.
Okay. So I'm going to subtract 10 from both sides. So this is now 3x minus 10 equals 2y. And then you're allowed to do the following. You're allowed to literally just flip it. Make the right side the left side the right side. You can always do this. You can always just flip or switch, move sides. Now it looks like what we want.
Yes.
Okay. Now, if you divide everything by 2, you get y equals 3/2 x minus 5. Does that look familiar to you?
Yes. The last equation.
It's the same. Okay. So when you go to graph it, and your teacher wants to see that you've graphed the same thing. So they want to see that you put a dot there, dot there, dot there. Now, my writing is pretty big when I do these, so I could probably show this. If you feel like this is hard to show, you then have to show it in words. You have to say something like overlap or same line.
Okay.
And like we talked about before, you have to say that this is both y1 and y2.
Okay.
Okay. Now your solution is correct, but there's no work to justify the solution. And that's the issue here. So your instructor was looking for some amount of what we just did here.
Yes.
Now, just to be fully clear here, where it says y1 and y2,
Yes.
your teacher is looking for the equations. So they want
Okay.
to see 3/2 x minus 5 and 3/2 x minus 5.
Okay. Okay, thank you.
Okay. Okay, so 5 and 6, like I'm not seeing any more markings on here. Is it just that you need to redo all of it?
Yes, you wanted me to do this, yeah.
Okay. All right, so for 5 and 6, we're going to answer that, but I really like to build these charts where we talk about flows. Okay, so if you're given a system of equations, there are two possibilities. It's either consistent or it's inconsistent. And we're going to talk about the difference.
Okay.
Inconsistent is the easier one. It means there's no solution. Now, do you have any idea graphically what it looks like if there's no solution?
Isn't there nothing there?
So there's 2 lines on the graph,
Okay.
but what do you notice about the 2 lines that I've drawn here?
They're both parallel.
They're parallel. So parallel lines never intersect.
Okay.
They just don't. Now, a lot of the roads in town are parallel. It's not a perfect example, but the idea is that you never intersect. Okay, and that's no solution. Okay, so if it's inconsistent, that means that they are parallel lines.
Okay.
Okay, so if the right path is no solution, what do you think consistent means?
It means they're not parallel.
Okay, definitely not parallel, but in terms of solution, is there a
They have
solution?
a solution.
Yes, so there's some sort of solution. Okay, but there's 2 possibilities. The first is what we like, which is they intersect in 1 point. Okay, and this is what's called independent. So if they intersect in one point, like we saw in problem 2, let me go back and, excuse me. No, problem 3. 3,
Okay.
where they're independent.
Yes.
Okay. Now, if they are, and that also means, sorry, I'm trying to read all the wording here. That also means that they are different lines. Because like you just said, like if they hit in a point, they're different lines.
Okay.
Okay. Now there's another possibility for solution. So the one we like though is that they intersect in one point, which means they're independent and they're different lines. The other possibility is that they, like you said, they intersect everywhere. And these are considered dependent. Was this shown to you in class this way, kind of in this chart?
No, but this is really helpful. Thank you.
Yeah, it's like, it's so much clearer. It's like, oh, it's paths. I pick the
Yeah.
path and I know. So if it's dependent and they intersect everywhere, that means they are the same line.
Okay.
Okay, so we're going to go back and look at the graphs. We're going to look at the graph for number 3. Do you have number 3 in front of you so I can start up here at the top?
Yes.
Okay, does it have a solution? Yes or no?
Yes.
It does. So we know we're over here on the left.
Okay.
So we know it's consistent. All right. Now, does it intersect in one point or intersect everywhere?
It intersects at one point.
Okay, so now we know it's independent. So both are true. It's consistent and it's independent.
Okay.
And then we know that because we can visually see it, that they are different lines. So for number 3, what your instructor was looking for, if I can just snip that in here, consistent, independent, and different lines. And then they're not parallel. I mean, I guess that's also another word here.
Okay.
Let's do the same thing for number 4. Okay, so I want you to look at your graph of number 4. And same set of questions. It's like, first of all, is there a solution?
Yes.
Yes, there is. There is a solution. So it's consistent. Yay, it's consistent. Does it intersect in one point or does it intersect everywhere?
It intersects in one point.
Okay, let's go back and look at the graph here. This is the graph you're looking at, right?
Yes.
Aren't these the same line?
Yes.
So they're on top of each other.
Okay.
So I'm trying to think of an analogy here. When you stack something, they're on top of each other. So,
Okay.
these intersect everywhere because they are the same line.
Okay.
I don't feel like that's clear, but
That makes sense.
okay. I can. So what I try to do is understand your perspective, and I kind of agree that it's a little odd to think that they would intersect everywhere when they're on top of each other, but that's
A little
the
bit.
case.
So at one point mean that there's like,
It's like an X,
yeah.
and everywhere is they're literally on. They looks like there's only one line,
Okay. Let me just write that down.
and that means they're dependent. That means they're dependent. So, like some of these lead to the next one.
Okay.
So this
And
is
they're both
for
parallel.
yeah. They're not parallel. No, they're not parallel. I'm sorry. They're not parallel. Not parallel. I misspoke there. So this is for number. Sorry, I'm trying to get. This is for number 5, and this is for number 6. There's really no work for that, but if you put this chart up, if you show this chart, to your teacher, they'll probably want to use it in their class.
Yes, I'll share that with her. Thank
Yeah.
you.
Yeah, and that'll make you, give you some, probably get an attaboy or something there with that one. All right, you ready to do number 7?
Yes. So here's what I've been struggling with. I don't know how to solve substitution
Yeah.
very much.
Okay, now let's talk about why it's substitution. Do you see that the second equation is solved for y?
Yes.
That's why it's substitution, because one of the variables has already been solved for.
Okay.
Now, in the first equation, do you see that it has a y?
But it doesn't equal.
That's okay. Substitution means to replace, to go in
Okay.
for. Like if you played a team sport at some point in your life, you went in for another player. They didn't put you in for 2 players, or 2 players come out and you go in. It's 1 for 1. So this
Yeah.
5x minus 3 is going wherever you see a y in the other equation.
Okay.
So you instead of the y, you're going to write 5x minus 3 instead of the y. We've taken care of that. Minus 3x equals minus 15.
Okay.
Now, what I think you're referring to is you liked it when the equations were both solved for y, and then you could set them equal to each other.
Yes.
And
That's
sometimes you can do that, sometimes you can't. But more generally, sorry, I'm just messing up here, minus 15. More generally, you replace. It's really the replacement method.
Okay.
So if you don't like what we just did, we can do the one on the right, but you're going to get the same answer either way.
Okay.
Okay, so let's go with this one here. So let's combine like terms. So you get a 5x and a minus 3x. What does that combine to?
It combines to 2.
2x
2x.
minus 3 equals minus 15. My screen, just give me just a moment here. Good. Okay. Now, I remember from last night, a little bit of a challenge solving this, but I'll just walk you through it. You add 3 to both sides.
Could you explain why you'd add 3?
Yeah. So, and the reason is it's related to this. You've seen this before.
Yes, PEMDAS.
So when you're simplifying, you go this direction. Okay. And what does that mean? It means you do parentheses for exponents for multiplication, division, addition, subtraction, right?
Okay. Yes.
But we're solving. So when you solve, you go the other way, which means you undo addition and subtraction before multiplication and division.
Let me just write that down real quick. Sorry.
Yeah. Again, I send you this at the end as a notes, and we're screen recording, so you'll have this as well if you want to look at it later. Yeah, I do want to go back and do a lesson at some point on solving equations with variables on both sides and this and that, but we'll keep going here.
Okay.
What is minus 15 plus 3? Looking at this on the right.
Would
here.
you add to negative 15?
Yeah, so when one's negative and one's positive, you look to see which one is further from 0. That's the negative 15. That tells you the sign of the answer. And then you take the numbers without the sign and you take the larger and subtract the smaller.
Okay.
So it ends up being 12, negative 12.
Yes.
And that's it's a little thing, but if it's not fully, in the brain, like you'll need some review on that. Divide by 2. So x equals
6.
What about this negative?
Oh, negative 6. Sorry.
Negative 6, good. It's a big deal. Big deal. Negatives are big deal. Okay, that's only half the answer. Like if you just wrote that and you walked out of the test, you get 5 out of 10 because
That
you
only counts for x.
Yes, you got to find y. So to find y, you can actually use either equation, okay? But you
Okay.
generally go back to the one that's already solved for y.
Okay.
So this is
Okay.
y equals 5x minus 3. Use this one. It's easier. So you take that value of -6, and like we talked about earlier, whenever it's negative and you're substituting, put it in parentheses. Substitute in parentheses. And now, like you were asking me, it is PEMDAS, right? You have to simplify in this direction. So you multiply before you subtract.
Yes. And then you get -30 minus 3.
Yes.
Okay. And then y equals -33.
Yes.
Okay.
Good. All right. So we are, I'm going to have to do more of the talking going forward so we can get through the rest of these.
Okay.
We'll just want to make, because we got to get through everything. I mean, that was the whole point of this lesson tonight. So solved by elimination. Okay. The reason this is elimination is because you can look at two of the coefficients and see that one is the multiple of the other. 10 is a multiple of 5. Okay. I'm going to just rewrite them down below here just to kind of frame this problem a little better. Okay. Now I'm going to multiply the first equation by 2. And the reason it's by 2 is because I know that gives positive 10y. 2 times 5y gives you positive 10y. Right. And you know, like I said, I want to get through all these. So just kind of go with this. That 2 multiplies everything. So it's 16x plus 10y equals 8. Okay, so if you're to show your work, these are the first steps. This is what your instructor is looking for. Okay, and you kind of did that in your answer. But now let me know when you get caught up to here.
I'm good, thank you.
Okay, now you're going to add vertically. So you're looking at the 5x plus the 16x. What does that add up to?
That added up to 21x.
20x, good. And how about the next one? Minus 10y plus 10y.
That cancels out.
Good, and that's what we want. And then you add the last term, so this equals 21.
Yes.
How do you solve this for x? How do you undo this 21?
Would you divide it by itself?
By 21, yes.
Okay.
Good.
I'm just not sure because they both equal the same thing.
Good answer though. It is correct. So,
Okay.
but again, like that's only half the problem, right?
Yes.
And you have to choose now. You have to choose one equation or the other to solve for y. So is there one that's maybe better than another? Yes, kind of, maybe. You know, they're not great, okay? I would tell you to probably use the first one
Okay.
because everything's positive. So 8x plus 5y equals 4. You're going to take that value of 1, and that's going to go in for x. Okay. So it'd be 8 times 1 plus 5y equals 4. Okay, so from here, you're gonna rewrite 8 plus 5y equals 4. Subtract 8 from both sides.
Yes.
5y equals -4. and divide by 5, y equals minus 4/5. So you got the right answer, and you have kind of the work. I mean, if I were really analyzing your work, I would have some doubts, but hopefully it's clear now. Hopefully, like, you see this, okay, I got it. I know how to do this.
Yes.
All right. So we got 9 and 10. We got to get through 9 and 10 here. So let me grab this. Number 9 here. Okay. So we're going to solve number 9 by elimination. Okay. And I'm just going to tell you that we're going to multiply the second equation by 3. All right. So that becomes 12x plus 63y equals 51. And then I'm going to bring the other equation down. This other equation I'm just going to bring down minus 12x minus 63y equals 51. And just like before, we're going to add vertically. All right, can you tell me what you get when you add vertically on the left here? What does this become?
Would they cancel out because they're both different?
Yes, but what does that mean when they cancel out in terms of a number?
It leaves the x and y.
Nope, nope. It's like you had 12 apples and you took away 12 apples. How many apples do you have?
0.
0. And same thing here. So this is 0.
Okay.
Okay, when they go away, there's 0. Like, we didn't write it. Let me go back up and show you this. Like, we didn't write 0, but it really is plus 0 here.
Okay.
Under the minus 10. You just don't write it. You don't need to write it. It gets, it clutters up what you're doing. How about on the right here when you add?
You 51.
You're adding though.
Oh, adding both. Okay.
Yeah.
102.
Okay. So now I've got a question for you. Is 0 equal to 102? This is
No.
not a trick question. No. This is false.
Okay.
Okay. Now, what you have to know is when you get, there's two cases, okay? If you ever get 0 equals a number, okay, and the number can't be 0, this means no solution.
Okay.
Okay. On the right, though, if you ever get number equals a number and they're the same, and an example would be like 5 equals 5 or -2 equals -2, this means all solutions or infinite solutions. Okay. Now, what does no solution mean graphically? It means they are, what have I drawn here?
Parallel.
Parallel. So you have to say that. And you've got the word in there. There is no solution. We used elimination, not substitution. The results mean that they're parallel. That means that they never, ever, ever intersect.
Okay.
All right, now I know we're kind of rushing here. I want to make sure we get through 10 so you get all this down, because I'm sure these are due tomorrow, right?
Yes.
Yeah. All right. Okay. Do you see how equation 1 is already solved for x?
Yes.
So wherever you see an x in the second equation, you're going to substitute in for x. So I'm writing 2x plus 3y equals 12. That's the second equation. Instead of the x, I'm now going to put in this 4y minus 5 in for x. 4y minus 5 in for x. All right.
Okay.
Now 2 times 4y, we're going to distribute in 8y minus 10 plus 3y equals 12. You're now going to what's called combine like terms. You got to combine that 8y and that 3y to get 11y. Let me know when you get caught up to this line here.
I'm good, thank you.
What would you do to solve this for y? It's kind of similar to ones we've done before.
You would subtract 10,
It's already subtracted, so how do you undo subtraction?
add.
Add 10. So 11y equals 22. And you'll divide by 11.
And y would equal 2.
Yes, that's only half the answer though. So you go back to the equation x equals 4y minus 5. And you substitute in for y, 4 times 2 minus 5.
And then you would subtract 8.
8 minus 5. Multiply.
3. And then x would equal
Yes,
3.
yes, yes. Good.
Okay, thank you.
Yeah. All right, we did get through everything, is that right?
Yes.
Okay, so I'm gonna just stop the recording here. Just if mom's there, we'll